The first images of the mission that tries to unravel mysteries of the dark universe. The first images of the mission that tries to unravel mysteries of the dark universe. The European Euclid telescope is ready to begin its quest to understand some of the greatest mysteries of the universe. Dark matter and dark energy. Images from the Space Observatory show that its capabilities are exceptional. Over the next 6 years, Euclid will scan part of the sky for some clues about the nature of so-called dark matter and dark energy. These unknown influencers appear to control the shape and expansion of everything in the universe. Scientists admit, however, that they know practically nothing about these phenomena, although they probably represent 95% of the contents of the cosmos. Neither dark matter nor dark energy are directly detectable. Our only hope of gaining some understanding is to trace its subtle signs in the things we can see. This will be Euclid's work to observe the contours, distances and movements of billions of galaxies, some of which took almost the entire age of the universe for their images to reach us. Somewhere in the statistics of this 3D cosmic map, the largest ever made, scientists hope to find answers. Horsehead Nebula. The Horsehead is a large cloud of gas and dust where stars are born. The Euclid research will be the most fundamental of the investigations, argued Professor Carol Mundell, Director of Science at the European Space Agency, ESA. We are human. We want to understand everything around us. Whether it's like ancient people looking at the night sky and drawing constellations in our caves, or trying to understand if the sun would return after winter. We always seek knowledge and vision, she tells the BBC News. We currently don't understand 95% of the universe, which is 13.8 billion years old. We are sentient beings who have existed for a small fraction of that time, but we could be the species that manages to discover everything, she says. Dark matter and dark energy are among the biggest enigmas in modern astrophysics. The first could be some particle that has not yet been detected. Astronomers infer its presence from the gravitational force it exerts on the matter we can see. The galaxies would fall apart if she weren't there. Dark energy poses a very different problem. It could be some kind of energy in the vacuum of space. Whatever it is, it appears to be working against gravity to pull galaxies apart at an increasingly accelerating rate. Perseus Cluster. The Perseus Cluster is one of the most massive structures in the universe. The Euclides telescope cost €1.4 billion, around $6.4 billion, and was sent into space in July. Since then, engineers have made small adjustments to the equipment. There were some initial concerns. Initially, Euclide's optics were unable to obtain a stable image. This required new software for the telescope's precise orientation sensor. Engineers also discovered that some stray light polluted the images when the observatory was pointed in a certain way. But with all of these issues now resolved, Euclides is ready to proceed, as evidenced by the release of 5 images he took on Tuesday. They are fantastic, said Professor Isobel Hook, who worked in the 1990s on one of the teams that first discovered that the universe was expanding at an increasingly rapid rate. I finally saw the images in full resolution on Monday and they really surprised me. We expected Euclid to perform really well, and it really met all of our expectations. It's a huge relief and really wonderful to see, said Hoke. NGC 6397, located 7,800 light-years from Earth. NGC 6397 is what we call a globular cluster. No previous space telescope has been able to match the breadth, depth and clarity of vision that Euclid can. The James Webb Telescope, for example, has much higher resolution, but it cannot cover the amount of sky that the Euclid telescope covers at once. This giant camera with hundreds of millions of pixels is now ready to survey the distant universe and objects across a vast expanse of the sky, a vast volume of the sky in space and time, says astronomer Mark McCoreen. It is only by observing large numbers of galaxies that we will be able to unravel these subtle signals of energy and dark matter, which are the essence of Euclid, says ESA.